Okay, so the first one says, find the distance between the 2 points. And the points are -3, 7 and -8, 14. This is very similar to the Pythagorean theorem. So we're going to use the formula distance equals the difference of the x's squared plus the difference of the y's squared. And it doesn't matter which ordered pair you put as x and which ordered pair you put as y, as long as you do the same one first for both. So I'm gonna start with my second. I'm gonna do this one first. So I'm gonna do -8 minus -3. Okay, so I've got d equals -8 minus -3. And then I'm going to square that. And then I've got 14 minus 7, and I'm going to square that. So my double negatives become a positive. And so I am left with -8 plus 3, which is -5. And then I have 7 minus 7. Okay, -5 squared is 25. 7 squared is 49. Now, one of the mistakes that I saw on this one was that students want to take the square root of 25 and the square root of 49 separately. Yeah. You can't do that. You still, like square root and stuff inside the square root is a grouping symbol. So you've got to do that first. So it's the square root of 74. I know that the quiz asked for an approximation to 3 decimal spaces, but we're going to keep it exact. I actually don't know what it was to 3 decimal spaces.
Threw off a couple of us.
Mm-hmm. Yeah, it was and I can see that. I meant to delete that on the quiz and I didn't. So the answer that I'm looking for there is the square root of 74. Okay. Our next one is midpoint. So our formula for midpoint is add my x's and divide by 2. And then add my y's and divide by 2. Okay? So when I add my 2 x's together, I have -2 and +4. Then when I add my y's together, I've got -6. And -4. Oh, -6. Did I write this down wrong? 6, 4. -6. Oh, it's plus. There it is. -6 plus -4. Divided by 2. Okay, so when we do the midpoint formula, we're adding those values together, not subtracting them. So -2 plus 4 is 2. So I have 2 over 2, which is 1. So my x coordinate there is going to be +1. -6 plus -4 is -10. And that gives me -5. So the midpoint of the line segment, so if you take a line segment, you connect these 2 points, the midpoint of that is 1, -5. Okay? Now we are moving to a circle. So this is already in the standard form of a circle. Okay? So I don't have to move anything around or anything like that. Standard form is x minus h squared plus y minus k squared equals radius squared. So in the formula, we've got that minus sign right there. And in this, we've got plus signs. So it's going to be the opposite. So my center is going to be -7, -6. That's going to be my center. And I'm going to go ahead and write it. I'll write it like this is x minus -7 squared plus y minus -6 squared equals 81. Okay, so our center is the -7, -6. Okay, we look at the 81 for our radius. 81 is the radius squared, so my radius is 9. So my center is -7, -6, and my radius is 9. Okay? This next one threw off lots and lots of people. Lots and lots of people. So, if I were to graph this, it would be a circle. Let's see. Oh, that's not going to work. Okay. So it's a circle at the origin. Okay? Let's start over. Okay, so if I were to graph this right here. Okay? Okay. And I know that's definitely not a perfect circle. The origin is right there. And if it was perfect, I could fold it over the x-axis, I could fold it over the y-axis, and I could fold it over both. So the answer to this question is that it is symmetrical to all three. So the final answer to this is all three. It's symmetrical to all three. But you have to show it algebraically. The question is asking us to show it algebraically. So let's show how this is symmetrical algebraically to the x-axis, the y-axis, and the origin. When I'm doing the x-axis, I replace y with negative y. Okay, that's what I do. So I have x squared plus negative y squared equals 9. So when I square that -1y, so think of that as -1y, -1 squared is +1, so then I'm left with x squared plus y squared equals 9. And that's the same thing as I started with. So yes, this is symmetrical to the x-axis. To find out if something's symmetrical to the y-axis, I replace x with negative x. Okay? So I'm going to have negative x squared plus y squared equals 9. So here again, I have -1 and x squared. That's going to leave me with +1 x squared. So I have x squared plus y squared equals 9. And yes, so it's symmetrical to the x-axis, symmetrical to the y-axis. Now, the fact that it's symmetrical to the x-axis and the y-axis, that doesn't necessarily mean it's symmetrical to the origin. Okay, so we still need to test that. So we are going to replace x with negative x and y with negative y. Okay, so I have negative x squared plus negative y squared equals 9. Negative x squared is just x squared. Negative y squared is y squared. And so yes, so this is symmetrical to all three. And I do think that confused some people because it was symmetrical to all three. Okay, now we are looking at whether or not this function is an even function, an odd function, or neither. So an even function means it's symmetrical to the y-axis. Okay, and we test that by testing symmetry to the y-axis, which is we replace x with negative x. Okay, now, an odd function is symmetrical to the origin. Oops. Symmetrical to origin. That means I replace x with negative x and y with negative y. But if we look at our greatest exponent, so my greatest exponent here is 5. Because my greatest exponent is 5, I don't have to test for even, because all even functions are going to have their highest exponent being even. So because this doesn't have an exponent whose highest degree is even, then I don't even need to test for this. I only need to test for odd. The way that I test for odd, so I'm going to rewrite this as y equals 6x to the 5th minus 9x to the 3rd. Okay, I'm going to replace y with negative y. I'm going to replace x with negative x. Okay, and when I simplify this, when I simplify negative to the 5th power, I get a negative. So this is going to be rewritten as negative 6 x to the 5th. When I take a negative to the 3rd power, I also get a negative. And a negative is a positive. Okay? So I'm going to divide by negative 1. And I'm left with 6x to the 5th minus 9x to the 3rd, which is the same thing that I started with. So that means that this is an odd function. Any questions about this one? Because I know this one was kind of good. Okay. This is probably the one that gave students the most fit. Okay, and I have some lines right here as I was coming up with my solutions key. Okay, the first thing that we're going to look at here is the domain. So we're going to look at the domain. The domain is my x values. So when I'm looking at a domain, the only thing I'm looking at is what x values are represented. So if I look at my line, my constant right here, all of these are covered because of this constant line, okay? If I were to write this point right here, this point is negative 5, positive 1, and this point over here is negative 2, positive 1, okay? So that's the ordered pair of the endpoints, and all of these x values are included in this piecewise function because of this right here. Okay, now, down here at my next one, I've got negative 2, negative 5. And here, I've got 0, negative 1. So because of this line segment, these are covered now. So those are all my x values that are covered. Now, if you look, I skip. Nothing is happening right here. So I don't have any x values in between 0 and 1. No x values between 0 and 1. Then I come back to this ordered pair, and it's 1, 3. This is just a continuous function, so I don't need to worry about this ordered pair right here because it's all covered. I keep going. So here, my last ordered pair is 5, 3. Okay, so I started back up at 1 and kept going until 5. Okay, so my domain, I start at negative 5, and I'm using a bracket for domain and range. Domain and range, we use brackets and parentheses, depending on. And I go all the way to 0 for my domain. Okay? Then I pick up again at positive 1, and I go all the way to positive 5. Okay? So that's my domain. My range...
Isn't it on domain you use the brackets until you use an infinity? And then
Yes.
So nothing's with a parentheses unless it's the infinity?
Correct.
Okay.
Correct. Okay, Now for here, we are going to look at the y values. So we're going to look at the y values. Now those ordered pairs are still going to be important, but instead of looking at the x values of those ordered pairs, we're going to look at the y values. So I start down here, and this y value is -5. So that's where I start with my range. I go all the way up here to -1. But just like I did in my domain, I am skipping this area right here. Okay? So that is not part of my range. But I pick up again at this ordered pair. Right here I've got -5, 1 and -2, 1. Because I'm talking about range, I'm focusing on that y value. So I start again at 1. And this one is also at 1 over here. So I don't ever drop below 1. Then I go all the way here. So it's my peach colored numbers that are my range. So I've got -5. And then I go up to -1. I do my union again. And then I go from 1 to 3. Okay, so that's my range. Okay. I think the domain and range is what threw people a little bit more than increasing and decreasing. So I am going to go ahead and write those ordered pairs again. So I've got -5, 1. -2, 1, -2, -5, -0, 1, or 0, -1, 1, 3, 5, 3, and 3, 1. Okay, and that is helpful when I start talking about increasing, decreasing, and constant. Now, when I'm talking about increasing, decreasing, and constant, I am only talking about the x values. So I'm back to only talking about x values. So the first thing I'm going to look for is increasing. Okay, and here is an increasing right here. Right there's an increasing. Okay, so I'm looking at the x values in between those two ordered pairs. So I have -2 and 0. Okay? And for increasing, decreasing, and constant, we typically use parentheses. Here is another increasing right here. So I'm looking at my x values, 3 and 5. You don't have to put the union right there. If you did, I would still count it correct. It's okay if you did or you didn't for increasing. Let's do our constant next. That means it's not changing. It's a flat line. This is where we're at a constant. Looking at my x values only, so I've got -5 and -2. That's where I am constant. My last one is decreasing. And it's right here from 1 to 3. Okay, and I know this one kind of caused some confusion for everybody. So I'm glad that we're able to talk about that one right now. Questions on this one?
No.
Good, 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 good. Okay, number 7. Number 7 is kind of one that I messed up. So let's talk about why I messed it up. So what I have here is I have an original line. My original line is -3x minus 8y equals -74. I have asked you to find the parallel line and the perpendicular line that goes through the point 6, 7. A parallel line, a perpendicular line that goes through the point 6, 7. So the first thing that I'm going to deal with is I am going to deal with the original line. I have to take my original line and I have to determine from that original line what the slope is. Because the slope of my original line is going to determine the slope of my parallel line as well as the slope of my perpendicular line. So it is important for me to know the slope of my original line. So I do this by saying -3x minus 8y equals -74. and I'm going to solve for y. So first thing I do, I add 3x to both sides. Okay, so I'm left with negative 8y equals positive 3x minus 74. I divide both sides by negative 8, and I get y equals negative 3/8x plus 74 over, or negative 74 over negative 8. When I simplify that, I end up with positive 37 over 4. Okay? But really, the only thing I need from this original line is my slope. Okay? That's all I need. Parallel lines have the same slope. So I am going to take my slope from my original line, and I am going to take this ordered pair. So I use y minus y sub 1 equals m times x minus x sub 1, and I plug everything in. The slopes are the same, and then I'm using the 0.67. When I do that, and this is where I mess up with my problem, when we simplify everything, I'm going to distribute my negative 3/8, and when I do that, I get negative 3/8x, and now what I'm doing is negative 3/8 times negative 6 over 1. I'm distributing negative 3/8 to the x, and I'm distributing the negative 3/8 to negative 6. When I do that, 2 goes into both of these. This becomes 4. Negative 6 becomes negative 3. Okay? So then I end up with positive 9 over 4. Okay? Positive 9 over 4. Now, I need to add 7 to both sides. So I have y equals negative 3/8x plus 9/4 plus 7. So I'm going to do that over here too, just so we can see what's happening. So I have 9 over 4 plus 7 over 1. I take my 9 over 4 and I add it to 28 over 4. That's because 1 goes into 4 times. 4 times 7 is 28. That's where I get that. 9 plus 28 is 37, and I'm left with 37 over 4. Now, that's not a problem unless you look too closely, because what just happened?
Then they can cancel out.
Well, it's the same exact line.
Yeah.
So what happened when I picked out this problem is my original line had this point on it, and I didn't realize it. Okay? So that's what happened. But you can still go through that process. You just end up with the same thing as the original line. And if you hadn't spent a lot of time simplifying in your original line, you might not have even noticed it. And it's fine. Perpendicular lines, we have the negative reciprocal. Okay? So the negative reciprocal slope, that's the slope of perpendicular lines. Negative reciprocal. So instead of negative 3/8, I'm going to have opposite sign, so it's going to be positive. And then instead of 3 over 8, I'm going to have 8 over 3. I'm still going to use point slope form of the line, which is this right here. So I'm still going to use 6 and 7. So I have y minus 7 equals 8 over 3 times x minus 6. So y minus 7 equals 8 over 3x. Then I have 8 over 3 times negative 6. So let me do this down here so we can see exactly what's happening. I've got to take the 8 over 3 and distribute it to negative 6. So I have 8 over 3 times negative 6 over 1. 3 goes into 3 once. 3 goes into negative 6 2. So I have 8 times negative 2 And that gives me negative 16. So I have minus 16 right here. Okay. My next step, I add 7 to both sides. I'm left with y equals 8 over 3x minus 9. And that is my perpendicular line. Are we good on that one? Okay. So now we are talking about domain of a function. Now, for this class, we limit our domain in 2 situations. We limit our domain when we have a variable in the denominator because a denominator of a fraction cannot be 0. Now, it's okay if the denominator is negative and it's okay if the denominator is positive, just the denominator can't be 0. So that's one of the times that we limit it. The other time that we limit it is when we have a square root. You cannot have negative numbers inside a square root. Okay? It's okay to have 0. Okay? You just can't have negative numbers. So we're going to talk about how to do both of those. Okay? My domain, f of x equals 1 over x squared plus 2x minus 15. Okay? I'm going to set my denominator equal to 0. So I have x squared plus 2x minus 15. And that equals 0. Okay? This can be factored. This can be factored. And it's factored to x plus 5 and x minus 3. The reason it's factored to that is 5 times negative 3 is negative 15. 5 plus negative 3 is positive 2. Okay? We set each one of these equal to 0. Okay, and I get that x cannot be negative 5 and x cannot be positive 3. Now, what I encourage students to do at this point is I encourage students to draw a number line. Okay? 2, 3, 4, 5. Okay? Here is negative 5. Okay? And here is positive 3. So I can have any of these numbers this way. I can have any of these numbers in here, and it's the numbers in between that confuse students. And then I can have any of these numbers right here. So, the domain of this written in interval notation, and students usually get that negative 5 and positive 3 can't be x, but they mess up with the domain. So I write negative infinity to negative 5. I do not include negative 5. Union, then I've got to write this in between. That's what students forget to write, is the in between. So then I have negative 5 to 3. Then I have another union sign, and I have 3 to infinity. So you have to make sure that you cover all the sections of the number line, including that middle part. Because a lot of people will do negative infinity to negative 5 and 3 to infinity, and they'll forget about that middle part. Okay? We good? Okay. So, this domain, I've got 2 minus x inside a square root, and I cannot have a negative number inside a square root, but it's okay to have 0. So for this one, what I do is I take 2 minus x, and I do greater than or equal to 0. 2 minus x is greater than or equal to 0. Okay, I'm going to solve for x, and we've got a couple places that we can get caught up on. 2 and negative 2 is 0. I'm left with negative x, so don't forget to bring down that negative with the x. So I have negative x is greater than or equal to negative 2. Then I divide by a negative. And if you remember, when it flips, why does it flip?
Because it can't, or it has to follow basically the negative.
Yes. Okay, so when you divide both sides by negative, you have to reverse the inequality sign, and that's what I did right there. So I have x is greater than or equal to 2. X is greater than or equal to 2. Okay? Now, you certainly can draw, or I'm sorry, that's less than or equal to. I think I said greater than. When we reverse it, it becomes less than. So your answer to this, if you were to draw it on a number line, just to make sure that you've really got it, it's okay for 2 to be part of your solution. And then we go down all the way to negative infinity. And that sounds weird. We don't think that that's the way it should be. So I would encourage you to check a couple. So the answer to this in interval notation is negative infinity to positive 2, and your positive 2 is included. So here's your answer in interval notation. And if that seems weird to you, go ahead and plug a number in. So let's use negative 1. So I've got 2 minus negative 1. Well, what do we see happens right there? It becomes positive. So then I have the square root of 3, and that's okay. Well, let's go ahead and try 1 also. So I have 2 minus 1. That's the square root of 1, so that's okay. Then let's try something on this side that's not part of my solution, that I'm not supposed to be able to use. So I'm going to use 3. So I have 2 minus 3. That's the square root of negative 1, and is that okay? It's an imaginary number, and so it doesn't work. And that's showing on this side where I don't have solutions. So if it doesn't make sense, plug some numbers in, and then I think you'll see that it does make sense. Okay, we've got one more. Okay, so what I have here is I have the points of the diameter. This is the endpoints of a diameter. So if I draw a circle, and I know my circles aren't great, here's the diameter, so here's my center right here. Okay, I am given these 2 points, that point, and I'm given that point. Okay, so I am told that this point right here is negative 6, 5, and I am told that this point right here is 4, 5. Okay, that's a definition of diameter. This is my center, but I don't know what that is yet. Okay, if this is my diameter, the center of my circle is the midpoint of this line segment. So I'm going to use the midpoint formula. Okay, so I am going to add my x's together. So I have negative 6 plus 4 and divide by 2. Then I'm going to add my y's together. And I'm going to have 5 plus 5 divided by 2. So I have negative 2 over positive 2, which gives me negative 1. Then I have 5 plus 5, which is 10. So 10 divided by 2 over 5. Okay, so that gives me the center of this circle. So the center of my circle is negative 1, 5. Okay, now I need to find the length of the radius. Now, when I was working this out a few minutes ago, I found the length of the diameter. So I plugged these 2 points into the distance formula, and then I had the length of the diameter, and then what did I have to do? Divide by 2. However, could I have put in my center and an end point and then gotten the length of the radius? Yes. So that's what we're going to do this time, because we're going to do that. So the distance formula. Distance equals the difference in my x values squared plus the difference of my y values squared, and then I add those together. So my x values, and I'm using my center and an endpoint. So my x value, I've got negative 1 minus 4, and then I'm going to square that. Then I have y minus my y value, and I'm going to square that. So I have negative 1, negative 4, which is negative 5 squared, and then I have 0 squared. So the distance is the square root of 25, and we know that to be 5. So what is the distance of my radius? It is 5. Okay? So now that I've got my center and I've got the distance of my, or the length of my radius, I can put this in the circle formula. Is it okay if I erase this? Okay? Okay. So the equation of a circle is x minus h squared plus y minus k squared equals radius squared. Okay? So I'm going to put negative 1 in for my h. So I have x minus negative 1 plus y minus 5. My radius is 5 squared. So my final answer is x plus 1 because I have double negative. Y minus 5 equals 25. So I have the center of my circle, the length of my radius, and the equation of my circle. Okay, and that is it. So I am going to